Hello everyone, welcome back. In today's video, we will be discussing about what is the meaning of section and elevation, and also what is the use of preparing a section and elevation in drawing by using AutoCAD. So basically a section is nothing but to show the details of footing and footing size or footing details which is below the plinth level or ground level. So this we say as another word, the details below the substructures or below the ground levels. So elevation is nothing but to show the details about the ground structure or ground levels. So this can be showing a door size or window size, all sunshade projections, all this is showed in elevations. Especially elevation is used for showing the staircase detail as well, or any kind of lift areas are there that we can see it in elevation views. So section is also used to show certain details like brick walls, layering or concrete layers, or thickness of floor slab, or thickness of flooring materials like damp proof course. So all these details are showed in section. So we'll be seeing this part in detail, how to create a section and how to create an elevation as well. So in order to know that, first of all we should know some basic footing size which we use in the civil engineering, and also the standard door size, standard window size, in order to help to make creation in the elevation part, and certain things like slab thickness or floor slab thickness and floor finishing thickness. So these are some basic things we should be aware about when you create a section and also in elevation part. So let's see in detail what is the meaning of this. So when you go in detail and see particular part, so these are some sample of elevations where you can see clearly the window size. So what is the window size? So we can clearly see and we can measure that what will be the window height and what will be the width of the window. So elevation help you to understand picturizations of objects like windows or doors or parapet wall, or in front elevation what all kind of architectural detailing you're doing. So these are all things we can see in elevation view. So this is nothing but a parapet, we generally call it as a parapet wall. So a kind of parapet wall. Here in this present diagram, instead of brick wall, we are using a handrails. So these are some handrail part. So railing parts are used, so like steel, aluminiums, so they keep like glasses. So these are some kind of, in front of your house you see we used to keep glass panels. So such kind of things we can show it in elevation view as well. Here you can see here the door size, so there you can see the doors. So what should be the door height, what should be the sill height, and with lintels, so you can see the lintels here. So this is a lintel, we call this as a lintel, and this portion we call sill height. So basically above the plinth we call this sill height. So these are the things which you should know basically in order to start a elevation. So these details we should collect basically in the field, or when you make the diagram we should show that these are the height which we need to prepare in a drawing, and the same will be represented in the field or during this time of constructions, right? So now have a look in detail about a sectional view. So in this diagram, if you see, a complete picturization of the sectional view is shown here. So what should be the beam size? So there is a section showing you what is the beam size. So we can see a reinforced cement concrete beam that is 300 by 400. So the cross section of size is given 300 by 400. So again, when you see the width of the window 1.80, including the frame size, including the window frame size, and covering the total height of the window 1.80 is shown here. So we can understand easily what will be a window size or window frame size easily from the section diagram. And similarly when you see the doors, so here you can see door height which is shown here, we can measure and see what will be the door height. So this also will be measurable, and here it is shown here 2.10 they are keeping for this a door entrance, and width of the door they are keeping 900 mm. So these are the details which is showed in the diagram as well. And coming to the flooring and roofing, so this is basically we called roofing portion. So basically on the top side we say roof, and the bottom side we say it as floor. This we call it as floor. So when you think about the roof and floor, there are n number of detailing work is there in sectional view which we should show. So before doing flooring we need to do some earthwork, and we do filling and we do compactions, and then we put some kind of DPC, that is called a damp proof course, for weathering purpose. So how much thickness of weathering purpose we need to provide in the site, and further that what kind of material you are going to use for flooring. So example, marble flooring you are going to use, or you are going to use a mosaic floor, or you are going to use a timber floors, or any kind of tile floors you are going to use. So those details, what is the thickness of the tiles or thickness of marble which you are going to lay in your house. So those thickness and the layers, how many layers, like kind of fillings are there, sand filling or compactions. So these are the things which will be showed in sectional view. So this is the main studies why we are preparing a sectional view in part of diagram. So right over here, if you see, there is a kind of a cement concrete with the plastering of a topping, that is 1:2:4 ratio. So this is a kind of a ratio which we mix in concretes, so when we do for flooring. And same way we see the thickness here, various thickness are there, like 20 mm are there, 40 mm thickness are there. So here they are using 40 mm thickness in flooring. And final finishing, we give a 8 mm thickness of part or 6 mm slab. So what are the type of slabs you are going to provide, that we showed in the top flooring size. Now on the top side, if you go roof side, again in the roof we have some details like a flooring roof are there. So roofings are there. So what you are going to provide in roof, like coats of bitumen for providing a DPCs, or rammed earthwork, or in terrace tilesing. When you see some kind of terrace tilesing, we put a tiles over there to resist the water. So these are the things are there. And then finally we have a thick slab, that is RCC slabs are there. So when you do the de-shuttering and make a part of building construction, you might be seeing that. So that is nothing but floor slab and roof slab which you do for the construction activities. And finally we have to show what is the parapet wall. So parapet wall is a boundary wall which you see in your house terrace. They have provided some boundary walls. So those walls are called as parapet wall. It might be generally a 0.5 meter to 1 meter height. Generally they are providing in the houses. And also the sectional view will show you the sunshade, the projection size. What will be the projection of your sunshade or any kind of slabs which you are providing, a sunshade or slabs, a cantilever slabs. So those projections are showed in sectional view. Now coming to the main aspect of a sectional view, which I already said, it is used to show the footings. So basically these will show the footings. So this part we call it as footing. So this footing part will show how many types of footings. There are a number of types of foundations are basically, we should know that. And under that we have wall footings. So these are called wall footing or step footing. Basically the step footings are provided in residential building when your columns are having a less loads. So when the columns are having a less load, we generally prepare a step footing. And also you need to take care of the soil bearing capacity as well. So here are the step footings are shown. So I will show you in detail how these calculations to be done and how these are done to be calculated in drawings. So let's go through ahead. Here, if you see here, this is a basic plan. So everybody know these are the basic plan which we already discussed, how to create a plan for a residential building with standard size of room, right? So once you decided of the room, now I want to cut a section. I want to see that particular view. So here I have taken an example of a section AA that is in X direction. So imagine this is X direction and this is Y direction. So two axes I have, so X and Y. So I am going to take A in direction of X, so X direction, and B to B, so that is in Y direction. This is in Y directions. We can say in this part, or simple we can also say in navigations. So we can also say in X and Y, or it's better to say in the navigation aspects. So north facing or east facing or south facing or west facing. So which side you are going to take a section. So if we are going to take a section like this, east facing, we put a word called east facing wall. So we are seeing the west facing walls. So if you are cutting a section over here, so south facing walls, so we are cutting a section for south facing wall, we are seeing it. So these are the things which you need to understand when you cut a section and when you see the objects. So coming back again here, so when you see in this particular part, section AA, so imagine that you are going to stand in front of this line, okay, and then you are viewing this side direction. So when you view this side, what all things is visible to you? So you see a wall, a column here, suppose any columns are there, then you're able to see this column portion, and then you're able to see the window, and then again you're able to see the wall, again you will able to see the doors, then again this particular wall you will be able to see, again this particular door, again this wall, again this particular corner you will able to see. So this we need to show it in diagram. So when you make this for a drawing or a diagram, that is called sectional view. So how to show that we will be seeing now. Similar way, when you talk about in y directions, so imagine that you are standing over here and you are viewing this side, so your eye point is this side. So this window is now cutted, so you can see the section line is passing on the window. What does that mean? So we are going to show the window section also, what is there in the window frame, that frame detailing also you are going to see it in sectional view. Then again you will be seeing about this wall, then again this particular window will be shown, then again this particular wall, again over this is straight wall, and you will be seeing finally this corners. So these are the sectional view which you are going to see in y direction. So how you see this output? So now coming to the output, so when you prepare this part, so how to see this in output? So here is the output. So when you see in a section AA, so as I said, we'll be seeing the corner column, and then we will be seeing about the window, any basic size of windows are there, we will be seeing the window, then again the wall portion will be visible to us, and then we will be seeing the door, then again the middle column, and then another window, door we will be seeing, and then last corner column we will be seeing. So this is called a section view. Now once you are able to identify or justify that particular portion, below that the column, wherever the columns are there is going to be a footing. So this is the concept. So wherever the columns are going to come, below that the column footing is going to be there. So this depth, so we call this is a footing depth. So basically from the ground level, so we call this as a footing depth. So we call this footing depth or depth of footing. So this is designed by soil bearing capacity. What is your soil bearing capacity? Depending on that strength, we will decide how much depth is required, like 1.5 meter, 2 meter or 3 meter depth. So these are generally we are providing in the field. So when a soil condition is in good enough. If your soil is very weak and you are planning for G+10 story building, then we generally prefer for pile foundations. We will go for pile foundation. That comes under the category of deep foundations. So these are the ideas which you need to know in the part of planning section. So now here we are not talking about a pile foundations or a deep foundation category. So simply we are discussing about the step footing or wall footing. So this size how to calculate I will tell you. Now similarly when you talk about other two columns, again we will see similar kind of footings are visible. So how to start this? So basically we put a plain cement concrete at the bottom, and then we start with RCC, and then we have a brick wall constructions for the footings, and later on we will fill with the sand filling will be done part. Now if you look at this particular portion where two arrow marks are shown, it's very clear to understand that DPC. So what is DPC? DPC is nothing but a damp proof course. So damp proof course. So what is this damp proof course? Is nothing but to resist rainwater, to resist the rainwater, groundwater level, penetration of groundwater level from the surface part or from the ground level contact or soil pressures. So these DPC layers is provided at a bottom portion. The similar kind of DPC is also provided on the rooftop in order to resist the rainwater. So two layers we can provide either in the roof level and also in floor level. It is recommended that you can provide DPC in both the case. So in the bottom of foundation footing columns as well as in the terrace part we can put it, so to resist the rainwater as well as the groundwater penetrations. So this may create some moisture in building, and it may spoil your structure, and it may leads to damage in buildings. So we need to resist the water penetrations in the building structures. Okay. Next part which you see a section according to elevation view. So when you see the elevation, So how you want to imagine that elevation? So I have kept the same size, but now I'm not showing which is a below ground level. So the detail below the ground level is missing. So in elevation, as I said already, we will not show the details which is below the ground level, or we will not show the substructure details. So this is we call superstructure. The structures which is above the ground level, we call it as superstructure. So those detail which you need to show in a diagram, so these are called elevation view. So little bit decorative works we can add. We can add some objects, or we can add some design centers like trees to add some sense. So we can add some trees or terrace plants. So we can add some terrace plants and garden works. So in front of your house, how it is going to look. So all these are the things which creatively we can do it, and we can add it in elevation. Right. Now let's go for to understand some basic sectional view, how you want to start a sectional view. So in order to understand how to start a sectional view, so this picture help you to understand how to draw a basic level of section view. So even a non-civil engineering student can understand this. So basically what is that is starting from the top. So let's start from the top. So here we have a 10 mm pressed tiles. So we generally go for pressed tiles. So you might be seeing in certain houses they used to put a tile at the roof levels. So why they put the tiles at the roof level is basically to resist the rainwater, one purpose, and it also give a good finishing at the rooftop. So in olden days they used to put bricks only. So in the very old constructions, if you see, you might be seeing only bricks. But nowadays the trend has been changed in construction. So in order to resist the rainwaters and to reduce the heat resistance as well as the cracks in the roof level, so now people are going for pressed tiles. So 10 mm size pressed tiles they are laying at the rooftop. And then surki is again for sloping purpose. So we give 75 mm in the construction time. So surki is like a kind of chunam. So that layers is also required for coating purpose. So we generally provide 75 mm thickness as a coating. And then we also provide, this is a RCC slab. So that is nothing but reinforced cement slab, cement concrete slab. So this is the roof slab. Basically we call in a word called roof slab. So we need to provide this. So this thickness, so how this thickness 100 mm is decided. So this thickness is decided depending on the load. So what is the load coming on the top of your building? So depending on the load, the thickness is decided in concept of design. So this comes in RCC design. So when you learn about RCC design, then you know how to calculate this thickness according to the loads, right? So here for example I have taken 100 mm slab thickness for just to show in a diagram, and then we see the total height. So this is the building room height. So basically this 3 meter is nothing but room height. So we need to keep the room height. Okay, now coming at the bottom portion, now let's come to the bottom portion. So in the bottom portion what you need to understand is basically from the plinth level. So what is called PL? So plinth level. So and GL is nothing but ground level. So GL stands for ground level. Okay, so in plinth level you need to understand that finishing portion where your exact flooring is completed, just contact below the soil level. So that is called plinth level. You might be seeing in your house a small projection at the front of your house. If you're not noticed, you can go and see. In certain house you see that projection will be there. So in front of your house a small projection will be there. So that projection at the ground level, we see that particular portion between the ground where the soil is there, above the soil layer, this particular portion. So this area we call it as plinth level. So in certain house this plinth level and ground level will be quite in same level. So we will not able to differentiate it. So it is depend on the construction site. So don't get confused here. Plinth level and ground level, it's not visible or you're not able to identify. So for non-civil engineering students, it will be very difficult to understand what is plinth level and ground level. So basically civil engineering students, you can easily identify what is a plinth level. So when you go into the site or when you identify the buildings, right? So when you identify the plinth level, so there if you see the floors, so what is the floor level starts. So what is the plain cement concrete? For floor finishing we give some plain cement concrete before you complete the flooring. So that we take it as a 20 mm coarse aggregate and you do the filling, and then we also do sand fillings. Then we put a sand filling, and before that we do with a earth filling. So starting from here, so first we do the earthwork, then we do the sand filling, then we put the coarse work, then we put a floor tile. 2 mm floor tiles are there, so we go for 2 mm floor tiles. So if you see overall the thickness of this particular area, it covers about 300 mm. So 100 plus 100 plus 100, so near about it covers 300 mm to 250 mm the flooring will be completed. Again I am talking about here, so this also the thickness depends on the amount of loads coming in the floors. So this also depends on the loads which is coming to the floor levels. So these are the idea. And now the most important thing, you can see the center line. So this we call it as a center line, so which is the part of your column head. So your loads are going to transfer over this. So from here the loads which is coming from the column, which is going to spread on the footing, so it is going to spread, it's going to get dispersion. So that we put a word called dispersion, it is going to spread. So this is how the building is done. From the column the loads will be distributed. Okay, so later on I'll come to the structural mechanism, how the loads will be transmitted from the building concept. Okay, so here is a look for you, a clear picture how the structure walls is done. So we basically consider any wall thickness. So basically we take 230 mm wall thickness, that is 9 inch. We take 9 inch wall thickness, or we may go for 115 mm thickness, that is 6 inch wall we will go. So now 300 is basically used for some kind of heavy wall construction. So 300 mm we take generally for heavy sections like RCC walls, okay, reinforced cement wall or shear wall. So we under that we call it as shear wall. So that comes under category of structural walls. So any load walls are there, so shear wall. So what is shear wall? So yes, shear wall is basically used in a kind of lateral resistant loads. We call the word called lateral resistance. So in order to understand, basically heavy wind is blowing in your building, so you want to resist that heavy wind blowing in your buildings. So certain positions or in the corners of the building we provide a shear wall. In such case we provide a reinforced cement concrete wall, so we say that as a shear wall. Or especially in the lift core, so we also say it as the lift core wall. So wherever the lifts are there in your buildings, so you might be seeing the 10-story building having a lift. So in such case we need to provide a lift core wall. So this is also we call as shear wall. So there all we provide this particular 300 mm thickness. So now how this calculation is to be done? So you already have 300, and next we need to have a thumb rule. So this is here 400. So this is calculated by what is our thickness T. So let's say this as T. This will be T plus 100. Understood? So whatever the thickness you are taking, T as 230, 115 or 300. So let's say 300. So these are the three sizes I given, right? 230, 115 and 230. So here we are taken with 300. So if this is T, the next level should be T plus 100. So 300 plus 100, it gives 400. Now you can clearly see this projection. Small projection is there. So how to calculate? So 400 minus 300, you get 100. So I'm writing here, simple to understand. So it gives you 100, right? Just divide this by 2, you will be getting 50 mm. So that's why all units are in mm. Here it's all units are in millimeters. So this is in millimeters. So 50 mm is the size. So this goes with 50, this goes with 50. Then we get 400. Now, so as I said, we need to understand this depth of foundation. So this is provided here 600 mm. So from here to here, we are providing 600 mm depth. So this is calculated value as per the field data. So here we are taking 600 mm. Next, if you see T plus 200. So next value go as T plus 200. So when you go for that, so again we have T as 300. So 300 plus 200, we get 500. So that is the calculation for next level. So step number 1 is done. Step number 2 we are doing. So 500. So again you can do the similar kind of calculation as we did earlier. So we reached 500. So previous step is what? 400. Again you get 100 divided by 2. you get 50. So here it is 50, over here it is 50. I hope now it's clear to you. The next stage calculation is called as 2 times t. So this is the formula here, 2t. We say it as 2 times of t. So when you see 2 times of t, what is t? Already 300. So 2 into 300, so you'll get 600 mm. So we get 600. Again, to calculate this, 600 minus 500. So again you get 100 divided by 2. So 50 mm will be projected here. So 50 mm and 50 mm is done. And simultaneously you can see the depth. So first footing and second footing here, we see the stages. The footing is given size 300. The next size is provided 400. From here to here, 400 mm. So that way we cover the first footing, second footing, and we reach the plinth height. Right. Now let's come to talk about this particular part. So when you come to this particular area, this is nothing but we need to calculate as 3 times of t. So when you come to this particular portion, we calculate it as 3 times of t. So now what is 3 times of t? 3 into 300. So that we get it as 900 mm. So we need to provide 900 mm width. So this size will be 900 mm width. Now calculate 900 is here, already 600 is there. So let's do 900 minus 600. We get it as 300. So when you divide it by 2, you get at last 150 mm projection. So this is called projection. So we put it a word called P. So this will be a projection at the bottom. So the footing. So that is 150 mm projections. So these are the values, standard values. So this is a standard value. It might be slightly vary according to the site and construction work. So slightly it will be varied. 175 few people will keep, 135 will keep. So these are some standard values. So 150 is recommended part. Now further that we need to do the filling. So we do the filling, the RCC work, and then again one more layer for with gravels we need to put one more. So that size is given as 150. So this is how the entire calculation of footing will be worked out. So this part when you complete, then we show this particular part in the section detailing. So now I'll take you to the drawings in order to make it simple. So when you go to the drawings, so it's easy to understand how you are making the drawings. So here you can see the diagram, so which we already discussed what is a plan. So when you do the plan and when you cut a section and see, so this was what we do it. So this we get it here, right? So this is how the diagrams are created now. So clearly shown the parapet wall at 1 meter height. Then we go for floor slab and DPC layers, and then if you go for section elevation view, so how that is shown. So I'm not showing any details below the plinth level, so I'm just showing only the plinth level, and above that structure what are the door height and what is the window height, these are showed in elevation view. So this is the idea of section and elevation, how you create. So now I will show you another example also. So these are some line sketch. These are some line sketch which you made in a different room size. So 15 by 12 bedrooms, 15 by 10 hall size and kitchens. And for that we have a line sketch with hatching portions. So I want to show with hatchings. So I am done. Now when you develop this particular line sketch, so line sketch is a basic idea, right? So what is the room size you need? So now when you develop into wall thickness, so what are the wall thickness you're going to develop? So with that particular wall thickness, you can show that idea here. So this is how the development of building plans for residential building you should understand. And when you go for industry, when you go and work with the industries, then you come to know how to create a section views and elevation view. So these are some industrial example. So you can see how they made that. So how this colorful is done. So how this is done in a colorful manner. So that is called layer properties or layer manager. So I'll be discussing about layer manager in upcoming part. So now let's start with basic part, how you are making a sketch. So in order to do that, so first of all, as I already said, you go with the units. So make sure which units you are using. So keep it in millimeter. I'm going to keep it in millimeter, right? Okay. Now let's start doing it. So quickly, and you can also make the text. So what are the text size you are going to give? So you can create the text size, provide your name, and give it your size. I'll go for 15. Click OK, set current. then close it. Then we can go for dimensions quickly. So let's go with new. Again, I'm providing my name here, continue, then go for arrow size. I'm going to give arrow size as 20, and primary units decimal. Text fix, I'm going to give my previous step which is available. Let me reduce to 16. Yes, right. So all this is done. Now done with the decimals, click OK. Right, set the current, then close it. Now we are ready with the certain steps. Now let's start with the simple footing diagram. So you can use directly with polyline. So I already said what is the difference between polyline and line. So better go with the polyline options. Okay, so imagine that we are having a floor height 300 mm, 3000 mm. Okay, so you should be aware about ortho. So I'm just clicking it. Yeah, 3000. So this is going to be height, and thickness of wall I'm going to take it as 300. Again, height I'm going to take 3000. Okay, so let's take this part. Once you're done with this, so let's start with the calculation. As I already said, 50 mm on left side, and down it's going to be 300 mm you can take. Then again you're going to start this right side 50 mm, right, then 300 mm. Now so you get 400 here. Then again you want to carry out with your 50. Then again you want to carry out with 50. Then again you want to do with 300. Then again you carry out with 300. Right, now again you go with 50 again. Yes, 50. Then again 50. Right, so one more step let me do. Then again 300. So I'm just going to take a 300 here. Right, now last step 150 I'm going to take. So here I'm taking 150. Right, now again here 300. Now let's complete it. So like this only we need to make the sketch. Right, so you got the sketch of the footings. How many step footing? 1 2 3 footings are there. Then RCC is there, and then we need to put a 1 PCC also. So I'm just going to add 150 mm and then add again 150 mm. Right, so this is how we done it. We can do it. Now you can do the hatching. So let's see the hatching part. So I already aware about hatching, so you can go for it. So we are just going to go, and you can reduce the scale. So go for scale 20. Right, then go for bottom RCC. So we need to go for RCC. So concrete, AR concrete. So go for it. I hope here is a line open. Sorry. Yes. Just let me close it. Okay, take a line, close properly. Okay, so be careful. In such case we can object tracking can be on, so to avoid this part, so just let me do it. Okay, and let me delete this part. Okay, right, now you can go for RCC, fill it. Now go for reduction of this. Got it? So bottom you can do it, filling. So go for sand filling. You can find a sand. Yes, here it is, sand. Sorry, not for that, for this portion, sand. Okay, now again let's go for top one RCC. Right, so this is how the sketch is done. So this is one method you can do it, and you can see the dimensions. You can measure the dimensions, so you can see what I discussed just now. You'll be getting the size 300 mm. You can improve the size. So let's increase the font size and arrow size. Okay, so these are the way we can do it. So now what I'm going to do, shortcut. So rather than doing this kind of part, so just go directly. You can start from directly from any size. You can take any size. Just go, if you want to give 3000, give it, and then start with your 50 mm and then go for 300 as you did earlier. So again 50, then again 300, then again you go for 50, then again you go for 300, then again 50. So 4, 5, 6, then 150, then again you go for 300, right? So up to here you are done. So let's go for up to here. So let me complete up to here. So take it for 900, right? So I'm going to take 450 off of that, right? Next part over here, so it is 300 mm, so I'm going to take 150. So this is what we done. So one off is done. So we have done one off of the sketch. So if you see the previous method, I have drawn simultaneously on both sides, left and right, I have drawn simultaneously. Now in this sketch, I am not drawing simultaneously. I'm just drawing only the left side section. So I'm just drawn only the left line part. Now you can explode it. So what is the meaning of X? So when you use X, so that is nothing but we are splitting all the polyline into single line. So use type X. You can find out the explode option. Just press enter. So your lines will be get splitted. So now select only the required one. Okay, just these portions are required. Use mirror option. Select the start point and finish point. Now you can see mistake is there. We didn't select the in between lines. So I'm just doing undo it. Okay, select properly and make sure all lines are selected. Yes, so all lines are selected. Now again this line and this line, right? Ensure it. Yeah, now go for mirror. Select the starting point, select the end point. Now you see once you ask it should be retained or not, you can select that it should be not to be erased. The source object should not be erased, right? Go for mirror, select the starting point, select the end point, and here it is no. So erase the source object or not. Previous object should be erased or not. No, I need that also, right? So prefer to go no. So now you can see the section is ready. Just complete the last line only. Then you can also go for 150 mm bottom, and then easily you can complete the sketch, right? So this is how we done. We can do one sketching. So we can go for this, and again we can go for sand. Okay, next we can go for brick walls. So this is kind of brick wall hatching. Okay, now increase the scale to 20. All right, finishing done. Now take from here 50 and then directly go for 3000. So your wall is ready. Now suppose you have some floor slab. So now you have some floor slab like this, and then you have some columns to be placed. So now it's easy to cut, copy, paste. So you have some column, so you can have this base and you can put it somewhere like certain distance, like 4000 mm, 3000 mm. So whatever the distance you have as per your plan, you can fix your columns. So you can fix your column easily. Whatever the distance, you can keep your columns. Now once the column is done, all together also you can do. You can completely select full objects and then you can place it. So to make understand, right now I'm making first column and then I'm doing the footing. So that makes you easy understanding. So what I did, I randomly placed the columns. So now you can see I have done for one sketch. I have completed for one sketch. I have done placed a column placing as per the diagram. Whatever the dimension is provided in your drawing, you need to take as per that. So just randomly I'm taking. So I just randomly placed my columns in this part. Now you can select this particular complete sketch, including a hatching, as well as be careful these lines if required. So now just copy CP and select this particular corner. Now just copy and paste it everywhere. So be careful, you need to select the corners very carefully or else you'll do the mistakes, right? So now see how fast the work has been completed. Now finish the last part. You can do the hatching on top portion, right? So now you can make the parapet 1 meter, so that is 1000. Then go ahead here, right? Now you can show some brick works on the top. You can have some brick walls. Go for brick walls. You can show some brick walls. You can increase it to 50, or you can go for 12, 10. Let's go for 0.5, right? So this might be better, or that's 0.75, much better. Okay, so now you can see the brick wall, that is a partition parapet wall. So we are fixed with the parapet wall. So suppose you have to show the floorings. So as I said, at least 100 mm. So you take 100 mm and then you can draw the lines, right? So this way we can also draw, and we can also do offset. So you can do offset. So if you go for offset alternative option, O, type O, that is called offset. You can type 100 and just select this line and just bring down. Another 100 mm you need, you can go for another 100 mm. Or you want to show 25 mm floorings and then you want to come for 100 as per the diagram, you can show that also. So as per the detailing, more detailing, if you want a 25 mm first, then you can show for first 25 mm, you can see 25 mm, and then next offset you need for 100, then according to that the second line 100. So what is that? That is nothing but, as I showed, this is a floor finishing and then slab thickness. So 100 mm slab thickness. Over here also we can show at the top level. Presently I have not showed it because I have showed brick walls. Right, now over here you need to trim. So these are unwanted lines. We use a command called TR. TR is nothing but trim options. So press enter. So type TR, press enter. Unwanted objects, you can trim it. So over here also these are some unwanted lines, right? So not inside the hatchings. We don't bring inside the hatchings. So just trim this portion. Right, over here first trim this portion and then come here. Right, so this is what we make a sketch. So now I hope the detailing of section part is clear. So this is how the section part is done. Now I do want to create an elevation part. So I want to create a elevation part for the same kind of picture. So how I will do? So in order to do that, just copy everything, CP, make a duplicate copy, just over the top or bottom, you can place anywhere. So let's place it at the bottom. Right, now just hide all this part. Okay, just delete this part. That's it. Now you can show elevation, create 150 mm, then come here. So go and join for this part. Right, done. Now you can add doors, window, what are the doors, window size you have. Suppose you have door here, go for the door 210, 1.20, then create a door here, then take the offset frame 50 mm, do the door frame. Right, now you can see the door. Now if you want to add the window here, take the height of the window, sill height 1000, then mark it, then you can make a window here. So now you to start window, you can do either of the way. Either you can use rectangle option, you can make a window size, or you want to do in line. So start from here, go for size 2100, then go again 100, then again 2100, then complete here. Now from this base I have taken the window. Now I don't want this line, so I'm just deleting it. Make the offset same 50 mm frame size. Now you can see the window size. So these are the window. More you want to do decorative works, you have all various options in AutoCAD. So just to decorate it, you can do that also. Right, so this way we can show it. So these are some windows we can show. Right, so simply you can make it. So these are some windows, these are doors, some doors, all these things. Or you want to add some steps, staircase you want to add, better you can take a rectangle also. You can show the staircase, so you can go for 50. Then again you take some distance, you can take 1200 or take 1000. Right, then again you can copy and repeat this. So just select it, copy, select this point and paste it here. Now you can show the steps. So some staircase is there, you are climbing and going inside your house. So this way we can show the much more detailing part. So this is how section elevation will be done in the AutoCAD. So when you do more practice and more sample diagrams and see more detailing, then you will be understanding how to create the detailed aspects. So more detailed aspects as per the requirement, we can do it. So I hope in today's video you learned about how to create a section and elevation. So in next video we'll be discussing about what is meaning of design center and what is mean by blocks and attributes and layer management in detail. So thank you for watching.